Johnson. I'm the National Account Manager for Noritz Tankless Water Heaters. So today we're going to be going over a bunch of different things with tankless, past units, new units, different technologies, all those different things, how to troubleshoot, just a whole bunch of different things about tankless. So with that, we'll go ahead and get started on here. So today we're going to be learning the differences between condensing and non-condensing technology. We'll be identifying common errors associated with tankless water heater installs. One of the biggest things that we see in the field that doesn't get installed properly is the gas sizing. So we'll be covering that as well. The venting options and clearances for the National Fuel Gas Code, condensing, piping, and how it needs to be piped through condensing water heaters, and then we'll go over error codes and how to fix error codes. So tankless water heaters, basically, biggest question we always get is how does it work? So with a tankless water heater, you do have the exhaust that's coming out of the top. There's a heat exchanger that's inside there, just basically small little tubes that the water's running back and forth through. With non-condensing, there's only one heat exchanger. With condensing units, there's two heat exchangers, which we'll cover here in a little bit. Every tankless water heater has a burner, whether it's a upward burn, downward burn. All the tankless water heaters have to be ultra low NOx in the United States, especially here in Utah. We have to be ultra low NOx, 20 parts per million or less to meet the current codes that are there. Every tankless water heater has a board. It's just a small computer, lets the unit know when to fire, when not to fire, and what it needs to modulate at on the gas valve, how fast that fan speed needs to be. It's calculating things in milliseconds all day long. So, so basically the way a tankless water heater works is first you turn on the hot water in the house. That cold water is going to run and it's going to hit this flow sensor is the first thing it's going to hit inside of that tankless water heater. So that flow sensor is sensing that flow. So if you have a gallon per minute running through that tankless water heater, it, depending on what that incoming water temperature is, it might only fire, say, at 50,000 BTUs for that gallon per minute to get that unit to temperature. So with tankless, they're all modulating. They all have a turn down ratio. So it's, if you have, say, 60-degree water coming in and you've got to get to 120 degrees, that's a 60-degree differential. So that's seeing what that temperature is coming through, and there's a little temperature sensor in that flow sensor. But then also coming out of that unit where it says valve right here, there is actually another temperature sensor there. Well, there's probably about, like with our units, there's about 9 different temperature sensors all over inside of this heat exchanger, through the burner, everything in there. But that valve has an exit temperature. So usually this valve right here is a mixing valve. So when that water, cold water comes in, there's actually a small tube that comes over to this mixing valve here. So it could be producing anywhere from 126 to 136 degree water inside this heat exchanger. But as it's coming down and leaving the unit, that small pipe that connects from here to there is tempering that water back down to 120 degrees. So we constantly have 120 degrees leaving that unit, so we're not going above or below. That's how Noritz does it, but other manufacturers do it different ways with buffer tanks and all these different things, but that's how Noritz does it. So that water comes up, goes through that heat exchanger, that burner's kicking on, that fan is blowing that exhaust out. It's flash heating that water and sending that water out and then out to the house. So with that valve control here, that valve is doing two different things. One, it's regulating how fast the water is going through the unit so we can stay at temperature, and two, it's tempering that water back down to keep it at temperature so we do not have any water hotter than the set temperature leaving that unit. So inside this unit, there's a whole bunch of different things going on all at the same time. So when you first turn on that water, this first line right here, this red line here, is showing that the flow sensor is sensing that flow, and then it's also turning that fan on at the same time. So most tankless water heaters, it's either a 0.5 gallon per minute or 0.4 gallon per minute for that unit to operate and fire. So with tankless, there's a minimum BTU and a maximum BTU. So most of the units that are put into Utah are either 180,000 BTUs or 199,000 BTUs. But their minimum BTU could be 18,000, 19,000 BTUs. So kind of a general rule of thumb is tankless needs about a 30-degree differential to be able to fire and go. So if you have incoming water temperature that is above, say, 95 degrees, and you have a flow rate of ½ gallon per minute, that unit might not fire, because if you're set at 120 and you don't have that 30 to 35 degree differential, that unit might look at that and say, I can't meet that minimum BTU requirement to fire. That was with a lot of the older units, they would not fire. We do have units that actually it has a super low BTU mode where it will actually modulate down to about 5,000 BTUs. So our minimum BTU is still 18,000, but with that super low BTU mode, it'll actually go down to about 5,000 BTUs. So, but there's always a minimum flow rate, which we don't really have to worry about high incoming water temperature in Utah. But unless you're out in Eagle Mountain, I did see last year with their tanks on the side of the mountains, and then when it gets above 100 degrees here, that their incoming water temperature could be anywhere from 87 to 92 degrees out there in some of those areas, which is really, really not the case in Utah. Typically, we see anywhere in the summer from 65 to 70 degree incoming water. So that flow sensor is going to kick on. It's going to sense that flow. So if it's changing all the time, people are turning things on and off, that flow rate is going to modulate up and down, up and down, up and down, which is also going to change that fan speed, which is also going to change the proportioning down here with that BTUs. So the more water that's going through that unit, the higher the BTUs are going to be able to heat that water that's going through, the less it's going to bring that down. So once that flow sensor is sensed, the fan kicks on, that igniter ignites the burner, the gas valve turns on, or the gas valve and the igniter turn on at the same time, ignites the gas. That gas valve is going to modulate up and down for whatever you have there. And then as soon as that flow rate drops below what the minimum is, so that minimum might be 0.5 gallon per minute to start, but like our units, we can modulate down to 0.24 gallons per minute going through the unit before it'll shut off. So if you have you turn on a faucet, it kicks on, you can actually take that water down to 0.24 gallons per minute and it'll still run. That's just on our side, but other manufacturers have different ways that they run that. But once you shut that water heater down and it doesn't, you just shut the water off, the fan will continue to run for 30 to 60 seconds. What that is doing is two different things. One, it's helping keep the heat exchanger temperature, since water's not moving through it anymore, keep that heat exchanger temperature from getting too high. And two, it's exiting out any unspent fuel or any flue gases that are remaining in those pipes, because with tankless condensing, you can vent in PVC and go horizontal. So we want to evacuate any flue gases, any unspent gas, anything that's inside of that pipe completely out of the system. So any questions so far? All righty. So the difference between condensing and non-condensing is quite a big difference. So over here on the left, with a traditional non-condensing tankless water heater, you would have that primary heat exchanger, that gas burner. Your flue gases would be about 400 degrees leaving that unit, which these old non-condensing units, you would see Cat 3 stainless steel venting. going off of that unit, running all the way outside, which your energy factor would be like a 0.80 or 0.87, which is still more efficient than a tank water heater. But sometimes, back in the day, that bending would actually cost more than the unit would if you were running like 20, 30 feet to get out of a house. But you also had to have different clearances around that pipe, where you actually had to have 1 inch or 2 inches to the sides and below, and like 7 or 8 inches above. It was really a pain to vent out one of those old non-condensing units. So with condensing, you can see there is a primary and a secondary heat exchanger. So the way this works with a condensing tankless water heater, which is 99% of what we sell here in Utah, the cold water comes in and goes to the secondary heat exchanger first, because we have the flue gases that are actually going through that secondary heat exchanger. So we're taking the temperature and the heat from those flue gases and injecting those into that water that's coming in through the unit. So it's actually cooling those stack temperatures down. So the exhaust coming out of the top of that unit is about 120 degrees. It can be cooler than that, depending on how much that secondary heat exchanger is actually pulling through. I have one of our Easy 111 units in my house, and my exhaust runs about 25 feet going out the side of my house, and I can put my hand in front of that, and it's actually cool coming out of the pipe. It's not even that warm at all coming out. So that cold water goes to that secondary heat exchanger first, which kind of preheats the water before it hits that primary heat exchanger, and then out to the house. So this will give you lower stack temperatures, so you can vent in category 4 venting, which is PVC, CPVC, or polypropylene. This also gets your energy factors up, which is from a 0.90 to a 0.96. I know in 2018, they changed everything from an energy factor to a uniform energy factor. So when you see data plates on tankless, tank, anything that's out there right now, it should show a UEF rating and not an EF rating. So the UEF rating is where everything is moving forward with all appliances now. So like we have UEF ratings on some of our units up to 0.97. UEF ratings, which the energy factor would be like a 0.98 or a 0.99, but we don't deal with energy factors anymore. There's still a bunch of different municipalities that I see around the nation that in their code books are still referencing energy factor, which will be changing here as those code books update over the next few years. But UEF is what everything's going off of right now. So any questions on condensing versus non-condensing right now?
So, can you hear me?
Yes.
Oh, perfect. Okay. I guess just a quick question on the UEF. How would that be significant when putting these in, or explaining to a client what the factors behind why this is beneficial to them? Is that beneficial to them? Is that just a different way in which we are measuring things? I don't know anything about energy expenditure, and so I mean, I guess a quick explanation would be great if you could provide that.
Yeah. So that unit, that energy factor, the way a lot of our installers explain that to a homeowner is, so that energy factor, if you're 96, if you're like a 0.96, 0.97 UEF rating, which makes that unit like a 97, 98% efficient unit.
Okay.
We really explain that to the customer is for every dollar you spend in fuel, 96 cents of that is actually heating the water, and 4 cents of that is going out the flue.
Okay.
With a tank water heater where you're like a 0.63 or a point up to like 0.70, so 63 or 70 cents is going to heat the water, but 30 cents of that is actually going out the flue. So the higher the energy factor, the more energy absorption is going into actually heating the water versus it going out the flue of the unit.
Okay, and when you say going out the flue, is that just energy lost per se? Just in the processes of.
Yeah, so if you're so basically from condensing to non-condensing, that condensing technology is taking that heat that's in that flue gas and preheating that water that's going through the secondary heat exchanger. So you're actually capturing more of that. So just like a high efficiency furnace, they're doing the same thing through that. They're sending that, they're taking that flue gas, which is preheating their coil. And so that's basically kind of reusing that energy and taking that stack temperature down so they can vent in PVC as well.
Right. So I guess in short terms, it grabs the heat that would have normally been thrown out of the unit, is now being used in a secondary heat exchanger to preheat that water. That's great. Okay, cool.
Correct. Yep.
Okay, thank you.
Yep, no problem. Any other questions? All righty. So with condensing units, they are going to condensate. So there is condensate that is going to be coming out of any condensing unit. So on the bottom of every condensing unit that's on the market right now, there is a condensate drain. Usually they have a trap that is built into the unit itself. So you will not, if you are running that condensate down to the floor drain, you're not going to want to put a trap on the outside of the unit, because everyone that I've ever seen has a trap on the inside of that unit. So on the bottom of that unit, it is going to have a 1/2-inch MIP adapter coming out of that. You can run 1/2-inch PVC pipe. You can run CPVC. You could run PEX. You could run whatever you're coming off of that. We just look at it as make sure that you're running everything on that condensate line in plastic. Don't run any metals or anything on that, because condensation is very acidic and it will eat away. If you put a brass fitting on the bottom of that and you're running it out, it'll eat away that brass fitting after a while. So, and also do not put any valves in that line coming out. 2 reasons: we don't want any kind of bottleneck in that drain as it's draining out using gravity. We don't want to put any valves or anything in there. Just like any other appliance, whether it's a water softener or whatever you're running to that floor drain, there must be an air gap that is there. So make sure that when you're running that down, you're running it not inside of the drain, but outside of that drain, so there is that gap in between there. So we require on our units a 1/4 inch per foot grade from the unit down to that floor drain. You can run this into a condensate pump. If you are running that into a condensate pump, make sure that you're following the manufacturer's recommendations on how far that pipe going into the top is stuck down inside of that condensate pump, sending that out. So we do have sensors inside of our unit, so if that condensate does back up, it'll throw an error code and let you know that, hey, it's backing up, which that's something that we'll cover down the line. So not here in Utah, but in other states, I have seen that with condensate. Well, actually, I jumped ahead a little far. So, so with older units that you would see out here, so this picture on the left is a non-condensing unit. So you can see that it is run just in that 4-inch stainless steel going up and out. But any unit that has a vent run that's longer than 3 feet, even with non-condensing, you're still going to get a little bit of, because of the temperature change from the flue gases to the ambient temperature around it, there will be a little bit of condensation in there. So typically right off the top here, if you were running it 3 feet or longer, you would put in a condensate trap. As you can see, this one does not have one piped up here on the top. You know, everything you guys would install in the future is going to be non-condensing. It's going to be condensing anyway. So that's not right, or not, you know, a great example of that. But over here on the right, you can see this right here is what that drain would kind of look like. You can see that this install, they didn't install that, so that condensate was just dripping straight on the floor. Condensate will eat concrete after a while, so you want to make sure that you are taking that all the way down to that drain on the outside. So There are areas where they will want you to neutralize that condensate coming out. There are residential neutralizers and commercial neutralizers. So for this like unit here, you would bring that condensate down into the bottom here. It would actually fill this up and come up out of the top of that. But what we don't want to have it doing is you don't want to have it come down and create another trap inside of there. If you are running it down and creating another trap inside of there, you'll want to put a Y into that condensate line to allow air to get in there to be able to push that through that trap. So you're basically just adding a vent into that condensate drain. So if you had this vertically versus horizontally like it is here in the picture, it could create a different trap inside of there, which I saw in a bunch of mod pizzas that we do a whole lot with up in the Pacific Northwest. And the contractor put that in and created a separate trap, so he kept getting condensate codes all the time. So once he added the vent, that went away. So if you have just one unit, you can use those residential neutralizers. If you have multiple units, like you're putting it in a large install like we have up at the VA hospital, and you are going to be doing a neutralizer, we do make a commercial neutralizer. Everybody makes a commercial neutralizer where you can run all of those together into that commercial neutralizer and send it out. So I know in Denver, the inspectors actually use litmus paper and actually test the condensate coming out of those units to make sure that you are neutralizing the acid in those units. Any questions on the condensating side?
The neutralizer, is that code here in Utah, or I mean, is that just something that's out of state, or I've never heard of that before? I guess I would ask,
Yeah.
what are the rules here for that?
Not code in Utah that you have to neutralize the condensate going out. I just want to make everybody aware that it is available. So in some places, depends on the job. Like I've seen some jobs on commercial sites where they require it through the spec. When the engineer's speccing it out, they'll throw neutralizers in, but normal install, residential, commercial, it's not required that you neutralize that condensate.
Okay, thank you.
Gail, I was going to say, if you don't neutralize that and you're on a cast iron drain, it will eat your drain out.
Okay.
Yes.
So it's best to neutralize unless you're in plastic drain lines. But some of these older houses, it eats those P-traps right on. So be careful with that.
Okay.
Yeah, if they've got cast iron or galvanized, older drainage and it's not plastic, I would highly recommend neutralizing that condensate so you don't eat away their drainage system.
Okay, thank you.
So any other questions on the condensing and the condensate? Alrighty, so we will jump over to the comparisons between the condensing and the non-condensing when it comes to tankless. So the first thing is going to be that thermal efficiency. So those UEF ratings. So there's two different ways that they gauge it, is either a UEF rating and a percentage rating. So non-condensing units could be between 80% to 85% efficient. Condensing units could be 90 to 95. Now with all the newer units that are coming out right now, those efficiencies are like 97, 98% efficient. They're getting very, very efficient with our pre-mix technology that we've brought out into the markets. That exhaust temperatures with the non-condensing could be 300, 400 degrees coming out. Condensing, the maximum temperature you'll see coming out of a condensing unit is 140 degrees. We have to keep that temperature down below 149 to be able to vent in PVC. We do have some commercial units though that you can turn up to like 185 degrees, where that stack temperature could get up to 159, 160. And same thing with our combination boilers. If you are going to that higher temperature, they suggest that you vent that in a CPVC or a polypropylene if you're going up to 180 degrees. So venting materials with non-condensing units, you had to use Cat 3 stainless steel, either 3, 4, or 5-inch stainless steel. With condensing units, you could still use that stainless steel. You could use PVC, CPVC, the ULC polypropylene, or in Canada, that S636, which is like a polypropylene piping. So if you are going out to somebody's house, or you're in a or you're looking at an older non-condensing unit and you do want to change that out to condensing, but it is 4-inch stainless steel or 3-inch stainless steel going off that unit, we do manufacture adapters that will adapt to that stainless steel. So it's stainless steel on one side and PVC on the other. So if you do have somebody that has one of those older units, you can actually adapt it to there, which with the Cat 3 stainless steel, it won't corrode with the with the condensation going through it. So you can actually bend it, that small piece coming off the top of the unit, into that adapter in PVC, and then it still runs stainless steel the rest of the way out. So we do make those adapters, so you do not have to rip out all that old stainless steel and rerun it in PVC. You could just adapt it to that current stainless steel that is out there. So venting clearances with old non-condensing, that stainless steel, you had to have like 1-inch clearance to combustibles, or some manufacturers required like 2 inches to the side, 4 inches below, and 12 inches above, and all these different things. But with condensing units, you can run it in PVC and plastic materials where it's 0 clearance to combustibles, so you can run it through a joist space, through insulation, through the girder at the side of the house, with 0 clearances to any of those going out. So with the amount of condensate that comes out of these units, so with the non-condensing units, you might get 1 to 2 drops per hour. With a condensing unit, you could get 1 to 2 gallons per hour of condensate. So that condensate coming out of those units, it really depends on how many gallons per minute you're running through that unit, to where how much condensate it's going to produce. So if you're only running 1 gallon per minute and you're running at 50 to 70,000 BTUs, it's not going to condense as much as if you were running 5 or 6 gallons per minute through the unit and you're burning at 199,000 BTUs. So the flow rate through a non-condensing unit, so at 199 BTUs on a non-condensing unit, you might be able to be at, say, 8 to 9 gallons per minute is the max. But with a condensing unit, because of the condensing technology and that water being preheated by that secondary heat exchanger coming through there, you can get up to flow rates of 11 gallons per minute going through those units. So it's that condensing technology has really pushed forward a lot of how many gallons per minute can run through tankless water heaters.
Hey, I have a question on that real fast.
Yeah.
So as far as the gallon per minute rating, I've heard in Utah, elevation can lower that as well as incoming water temperature. So what would be a standard GPM in Utah, say like Park City? How affected is it by the elevation and incoming temperature?
The elevation, we have settings in the unit that offset the elevation side of it, so it knows what elevation it's at, so it can still keep up with the exact flow rates that we have set for all of those units. So just to kind of give you an example, a unit that's 199,000 BTUs, like our Easy 111 unit, it's 11.1 gallon per minute is what we say that unit is, but that 11.1 gallon per minute is at a 35-degree rise. So in our books, we actually have a flow rate chart. So in Park City, if you had an Easy 111 that's 199,000 BTUs, we always size off of winter temperature. So we would look at like a 70-degree rise instead of a 35-degree rise there, which would be like 5.9 gallons per minute going through that unit.
Right. Okay.
So it would be able to produce like 5.9 gallons per minute. In the wintertime, in the summertime when the water's coming in a lot warmer, I mean, it could go to like 7.5 to 8 gallons per minute. But we always size everything off of winter temperatures. And so in the summer, it's just a bonus that they can get more water. But we always size off that winter temperature. So with 199,000 BTUs, you're like 5.8 or 5.9 gallons per minute. And then with 180,000 BTUs, you're right around 5.1.
Awesome. Thank you.
Yep, no problem. So any other questions on the condensing side? All right. So then we will move on to the mounting of the tankless water heater. So all tankless water heaters are going to have, well, different types of mounting on how to mount it, but every single one of them is going to have a upper bracket and a lower bracket. So at the top of these units, you can see here, there's this upper bracket that is up here. You're always going to want to make sure that these units are mounted level on the wall. This is a picture of kind of some of the older units where you would span 2x4s across the wall, or people use unistrut or whatever you're looking to do to mount that to that wall. So the top bracket has up here in the bottom bracket. So within the code, like with the tank water heater, you have the top third and bottom third for seismic. For units, these brackets are your top third and bottom third. So when you are installing tankless water heaters, make sure you're affixing the top bracket and the bottom bracket on there. Don't just do the top bracket. Seen a ton of those out in the field where people just mounted the top bracket and didn't do the bottom bracket. It's always good to have it mounted to the wall correctly. You don't want it to have any room for it to not be mounted correctly and have somebody smack it or something, or like the earthquakes that we've had over the last couple of years, being able to do anything with that unit. So the mounting screws do come in the packages for you to mount those to the wall, whether you're mounting it into 2x4s or you're mounting it into concrete or whatever you're looking to do on those. Our newer units come with a different type of mounting bracket system where the mounting bracket actually comes in the box separately. So you actually just take the bracket, mount it on the wall. These endpoints on here are 16-inch on center. So if you are mounting it on a 2x4 wall, you can line it up, mount it to the stud. You don't have to put any backing in there or anything like that. On that, you can just mount it to the wall and go on there. So we actually have a unit that bracket actually shows you the in and the out on the top on there. So if you are running PVC to that, it'll actually line it straight up, and it does have some fudgeability where you can move the unit to the left, move the unit to the right to line up piping and different things like that. So they've really come a long way on the mounting options on the top of those units. So a lot of these units will show what the clearances need to be for the unit itself. Mounting it on the wall, it's also in the install manual as well. So make sure you pay attention to those. So like for this unit right here, off the top of it, they want to have a clearance of at least 12 inches off the top. Off the back, there's a 0 clearance. Off the front, they want at least 4 inches, and then to the sides, 2 inches. A lot of ours now the code is you need to have at least 24 inches in front of the unit to be able to take the door off to actually work on it if you needed to, and then 18 inches to the sides. And that 18 inches to the side is just because the data plate and everything is on the side of the unit, and you need an area where you can actually stick your head in there to see what the data plate is. So before we jump into the gas side, anybody have any questions? So again, it's going to have a top bracket and a bottom bracket, so you can mount that to the wall and make sure that you mount both brackets. So gas requirements. So I'm sure everybody's been through RMGA trainings and Everyone knows how to size gas lines. With Utah, you do have to derate for the elevation. So same principles apply when sizing tankless water heaters. You can't just replace a 40-gallon water heater and throw 199,000 BTU tankless water heater on the wall and expect it to work just fine. Some houses have enough gas coming in, but a lot of houses that are out there, you're going to need to upsize that gas line coming in. One thing I've seen a lot of people do is they'll actually just run a gas line straight off of the meter directly into the tankless water heater, so they don't have to upsize the whole system. They'll just run it straight off of that meter, because if you pull it straight from the meter straight to the tankless water heater, if it has enough CFM through that meter, you don't need to count that as your whole home run. But for that gas sizing, you want to add up all the BTUs from all the gas appliances that are in the house, using the sizing chart and your duration that you're using to find what that total BTU really needs to be. So within this diagram here, the total BTUs is 20,000 for that range, which usually ranges are about 60,000, 100,000 for that furnace, and 199,900 for that tankless water heater. So distance from here to there, if you go back to this chart, if we're at 319,900 BTUs, and we go back to this half-inch pressure drop chart, which is here in Utah, we're 60 feet, we're 319,000 BTUs. Our main line would have to be 1.25 inches coming in. So we would have to be 1.25 inches till we get to the branch, and then since we're 199,000 BTUs coming over here, and we're 60 feet from the meter, then we would need to be 1 inch from here all the way over, and then we could reduce down to 3/4 to go into that through the gas flex, or if you're not using gas flex, if you're hard piping, or if you're using CSST, you would want to go. So when you are flexing from your hard iron pipe or whatever you're using going in there, with the gas flexes are just fine, but you need to check the rating tag that's on that gas flex to make sure it will deliver enough BTUs for that unit. So there's a lot of gas flexes out there that the end connections are 3/4, but it's still only a 5/8 OD, or it's a 3/8 OD. I went to a house years ago where we walked up to the house and it sounded like an elk bugle going off inside of this house, and they had like a gas flex that they got from Home Depot that was like a 3/8 OD gas flex, and so it was pulling gas through there, and so it was screaming as it went through that flex. So rule of thumb, gas flex going on there, a 7/8 OD gas flex is what you would like to see going through there. That's going to be able to handle that 199,000 BTUs or 180 or whatever that BTU load is. Just make sure that that gas flex that you have there will carry that load. Because we've seen a ton of installs where the main line coming in is just fine, but the gas flex is too small and it causes problems with the unit, because if we can't get to 199,000 BTUs when that unit is at full capacity, you will see error codes happening, and we've seen a ton of those gas flexes we tell people they need to change out because they put it in wrong. With CSST, I know it's become very, very, very popular in new construction and in the retrofit applications. So this type of install where you have a 2-pound system coming in to the house, and then you're branching off everything to individual loads inside the house. What we ask on this is, if you are doing a 2-pound system going into that house right there, we want that regulator to be at least 3 to 4 feet away from the actual appliance. So if this T coming off this manifold going down over to the tankless water heater is less than 3 feet, we want to have at least 3 feet of piping to get through there. The reason for that is a lot of times these regulators will bleed and bleed pressure through. And if they are getting above what our water column is on our units, it's going to throw an error code. So If it's within 3 feet behind the unit, you shouldn't see that. There are a lot of new regs that are out there too that what they call zero clearance regs, where they have manufactured that into those regulators. Like we had a huge job in Colorado a couple years ago where they actually had regulators that they could actually put like directly on the units because they didn't bleed through or pressure or anything like that. So there are some of those that are out there, but rule of thumb, try to keep it at least 3 feet away from there. And also check the manufacturer's BTU load on their CSST because it's different than it is for iron pipe. So each manufacturer of CSST has different BTU loads that they can run through their pipes. So make sure that you are checking that BTU load on that CSST to make sure that it is exactly what you need for that system. So I mean, the biggest issue we see with tankless water heaters is they're not sizing the gas lines correctly. So kind of a couple examples with this unit here. They've got that reg that's right there on the gas line. It's 2 inches away. They were getting 11 codes, which is an ignition code because it had too much pressure going into it. Same thing with this setup right here. That reg is a little too close to that unit there. We would like to see that at least 3 feet away. The newer units don't seem to mind how close that regulator is, but if you're within 3 feet, sometimes it'll mess it up. But before we move on, any questions about the gas? Alrighty, so
I have a question, if you don't mind.
yeah, go ahead.
There are some who claim that the if the gas line is sized a little bit under what it should be or what it's indicated in the code, that the unit itself will pull the gas through at a higher rate. Is that true or not?
Yeah, so with so like we do have units like our easy units and our units that do have negative pressure gas valve. There's a lot of manufacturers that are starting to use those negative pressure gas valves. We do have a competitor that says that their negative pressure gas valve will pull 100 feet through a half-inch line and give you 199,000 BTUs. I'm a plumber at heart. I've plumbed for many years and worked with a lot of gas lines, and it will help pull through, but it's not magic. It's not going to pull 199,000 BTUs through a half-inch line 100 feet. So we do have a lot of our units are half-inch capable. I call them half-inch capable, not half-inch ready. You still have to have enough gas in that line for it to actually work the correct way to pull it through. So you still need to size it. I mean, if it's close, it will help you fudge it a little bit, but it's not going to help you gain 100,000 BTUs.
Okay, thanks. You're calling that a negative pressure what?
So it's a negative pressure gas valve. So that negative pressure is actually helping pull gas through there. Same because we have an air gas mixing fan that's actually helping pull through that negative pressure gas valve to help kind of pull gas through. So there's a few different manufacturers, tankless water heaters that utilize that technology like we do. But I'll never tell somebody that they're okay just to throw a tankless water heater on a wall and that our negative pressure gas valve is going to suck enough gas through that line to make it okay. I always tell
those negative pressure gas valves are internal to the unit then, correct?
Correct. Yep.
Okay.
Yeah.
Thank you.
Yeah. So I mean, always size it correctly, because I've seen way too many people have to go back and resize gas lines because they were told that they can, it's half-inch line compatible, and they'll hook it up and it'll work just fine until it starts getting to a higher demand. Like it might work well with just one shower in the summertime, but then all of a sudden the winter hits and it's having to use more BTUs to change it, and then all of a sudden they start throwing error codes because you're either starving the furnace or you're starving the tankless, and both of them start throwing error codes because there's not enough gas for both to run at the same time.
There's, this is Vic again, but I see there's a lot. I have to go in on resize for people because they put it in there and it says, well, it says that it could be a 1/2-inch gas line, but if you read the fine print, it has to be less than like 12 feet. It has to be the first thing on the gas line, and they don't realize that, you know, the furnace came off before, and that's when they start starving it, is when the furnace kicks off. So you got to make sure that you read the directions, because it says you can use 1/2 inch, but there's a lot of things that you have to follow to get it to work on.
Yeah, so like in our like our Easy 111, 199,000 BTUs, in our book it says, you know, 1/2-inch line up to 30 feet, but that's using the National Fuel Gas Code 3-inch drop chart, which is this chart right here, where with a 1/2-inch gas line at 30 feet, it says 250,000 BTUs. A lot of places around the United States are 1/2-inch pressure drop. So with that 1/2-inch pressure drop at 30 feet, I'm still at 3/4. I'm 100. So, but there is a lot of places that do have this 3-inch pressure drop, where that 1/2-inch line at 30 feet, 250,000 BTUs has worked just fine. But that's only having the tankless water heater on your gas supply and nothing else. So it has to, you know, there's a lot of fine things to it. I always err on the side of caution and you know, make sure that you have enough gas there no matter what. So any other questions about gas? All right. So moving on to water. So on the bottom of our units, or on everybody's units, there's, well, we have units that have top mount connections too for the water, but they'll always be labeled. It'll say hot, cold. The gas valve will say gas on it. If you look at the bottom of these, a lot of these you'll see these little little barbs. Those are drains. So if you did have to drain down the heat exchanger, you could put a small piece of tubing that, or just twist it. You twist it about halfway out, it'll start draining through the middle of that. So you could actually drain down the heat exchanger if you were in a cabin situation or something like that, where you're going to winterize it. You can drain it out there. But the hot and the cold are always going to be labeled there. So hot and cold and gas. The gas is usually a different color than the water connections. The water connections are usually a copper brass color, and the gas connection is a silver color. Nothing will void your warranty on a tankless water heater faster than hooking the cold line into the gas connector on the bottom of the unit. And I say that not to be funny, because we've seen it multiple times where people have hooked that up wrong. So just make sure that you are hooking up the correct things on the bottom. So most of the residential, or all the residential units, and most of our commercial units all have 3/4-inch connections. We do make some larger BTU units, like up to 380,000 BTUs and 300,000 BTUs, that actually have 1-inch water connections on the bottom. But everything residential is going to be that 3/4-inch water connection on the bottom. So one thing, so with some of our units, they come with isolation valves. Some of the units don't come with isolation valves, but isolation valves is something that we highly recommend that are installed on every single install that is put out there. One, with the isolation valve, it does come with the pressure valve that is required for the install. It's a pressure relief valve. It's 150 PSI. It actually screws right in here on the hot side of that isolation valve. So with tankless, it's just a pressure relief valve. It's not a temperature and pressure relief valve, because we are not storing any water. We don't have to have the temperature side of it, because we're not going to store and make hot water. With tankless too, you do not need an expansion tank when installing a tankless water heater. If it's a recirc unit, or you're adding a recirc pump to a tankless water heater, then you do need to add an expansion tank to the system because you are introducing thermal expansion into the system. But with just straight tankless water heaters without recirc, you do not need to have a expansion tank because there is no thermal expansion within the system, because as soon as you turn on that faucet, that's your thermal expansion within inside the house. As soon as you turn it off, the unit turns off, and there's only about 1.5 liters of water that's in those heat exchangers, so you do not need a expansion tank. Having an expansion tank is still a great idea to have an expansion tank on the system, but it is not required with tankless water heaters. But one thing that's these isolation valves are for is with tankless water heaters, they do require maintenance. We do require, if you do not have filtration in there, that these units are flushed once per year. So these little valves that are sticking off the side of this, that's what these are for, is so you can isolate just the unit within itself. And then you can flush those units with either a CLR type mixture or a food grade vinegar, which we'll cover here in just a little bit. But the isolation valves also have your shut-offs for the hot and the cold already built into them as well. So we highly recommend that isolation valves are installed on every single unit that you are installing. So any questions on the isolation valves? All right, moving forward. So water treatment guidelines, there's many, many different water treatments that are out there for hard water. And there's many different requirements for hard water between manufacturers. So there's some tankless manufacturers out there that any hard water that runs through their unit voids their warranty. Or they have different parameters. Ours is anything above 7 grains requires filtration. But then we also do if either the filtration or it's flushed once per year. With our units, we actually have a specific flush technique that needs to be done to the unit, where you actually put a connector together that puts the unit into flush mode, which actually records the date and how many times that unit's been flushed. So if you were to call our tech support because you had something going wrong with the unit and it was, say, the heat exchanger was leaking, and we could actually look at it and see how many times it's been flushed and how many days it's been since the last flush. So the best thing for any house, especially here in Utah, is water softeners are great for tankless water heaters, for any water heater actually. But you can use those small tripolyphosphate filters, Silifos, anything that's physically treating the water in some way, whether it's coating those minerals or removing those minerals, is great for tankless. It's going to let those units run. Like one of our easy units have a 25-year warranty. It's going to let that unit, as long as you're treating that water and flushing it, it's going to last 25 to 30 years. So some water quality issues that you'll see, if somebody has too acidic water, the pH level lower than 4. So this was like deionized water at an ice rink. So that actually ate away a lot of that valve. Water quality, having hard water and going through a recirc system will gum up the inlet filters that go into there. So every single one of our units on the inlet going into the unit, it does have this little screen. So it is blocking anything from being able to go through that unit that is a foreign debris, but it will scale up at the time. So any questions on the water quality side?
Yeah, I've got a question real fast. So you say a softener would work, or really you said anything that physically treats the water or coats it. So like something like a, I think it's called a Nuvo. Would that be sufficient?
Yeah, so the Nuvo is just adding citric acid to the water. And so it's actually bringing your pH of the water down. So it's not actually, it's not like, I mean, we would have to test it to really say that it's okay, but I know that they're just adding that citric acid to the water, so it doesn't actually physically treat the water in any way. You're just adding acid to the water to make it bring the pH level of the water down, and it kind of softens the hard water minerals. So what we're looking at is something like a water softener where it's actually removing the magnesium,
Right.
calcium, or tripolyphosphate, silifos, any kind of scale shield that will. So scale shield, all that scale shield is doing is just coating the jagged ridges within those minerals, and so it can't stick to anything in the system. It just goes through the system, so it won't stick to anything inside of our units.
Right. Okay. Thank you.
Yep, no problem. So any other questions on water quality? Alrighty. So we'll move on to the electrical side of it. So, so every single one of our units will come with a 6-foot power cord already installed on the unit. Some of our outdoor units will not come with power cords, but the majority of our units do come with a 6-foot power cord. Same thing with our with all the other tankless water heaters out there, they will come with that power cord attached. So we do not require that you have a GFCI outlet for it to be plugged into or be on a dedicated circuit. So you can just plug it into the wall. We do recommend that if you do need to run that cord longer than that 6 feet that is there, that you actually get a high grade. So if you have to run it 12 feet, we don't recommend that you plug that into an extension cord and then run that extension cord out. We would ask that if you need to run it 12 feet, get a 12-foot extension cord, cut the end off of it, and wire it directly to the unit and run that cord straight off. We don't want that point in between. So with our units too, you can hardwire it too if they want to hardwire it in the house, have it on its own breaker. I've seen a lot of people do that. A lot of builders are doing that. You can do that as well. But with tankless, one of the people always say the drawbacks with tankless is if the power goes out, you can't have hot water, which is not the case with tankless. I mean, it is the case with tankless if you don't have some sort of backup system. So you can use like a regular battery backup that you would use for a computer to plug that into those units. So like my unit, if it was plugged into a battery backup, that unit I'd actually be able to get 16 hours of burn hours of that unit running through that battery backup because we use such little electricity through the Noritz Tankless Water Heaters. So I could actually run that thing for 16 hours on that battery backup and it would work just fine. So you can run them off solar as well. We've got a lot of units that are put in cabins that they don't have electrical going through there. They all run off solar. But the only thing with solar, it needs to be clean sine wave solar for that unit to work properly. So also with if you're running it off a generator or anything like that, we always ask that it's like an inverter generator, so it's not peaking and going up and down, that is keeping a constant electrical current going to that unit. So before we jump over to the controller side, anybody have any questions about the 120 side of the units? All right. So with a lot of like some of our units, we have the controller built into it. Some of them are separate. There's many different ways that different manufacturers go to market with their controllers. But our controllers come separate in the box for like our EZ series and our NRCR series. So when you do break into one of our units, when you pull the top off the box, there is styrofoam that is up there on top of the box. That's where the bracket and the controller is. So when you take the top off, don't throw the top away or you won't have a controller or a bracket to mount it to the wall. So in there has a cord that connects to the bottom of the unit. This controller can either mount to the wall, it can mount to the side of the unit. It comes with a big sticky pad that you can stick on the back of it and stick it to the unit. I always recommend that you put it on the side of the unit or on the wall, not on the front of the unit, because that controller is also your diagnostic tool. So if you ever had to work on that unit or do anything with that, if you take the cover off, your diagnostic tool just went with the cover. So I always recommend that you put it on the side or on the wall. You can't put it on the front. You can do whatever you want to on that, but you know, typically when I'm going out to a unit, I have to diagnose it. So I like to have it in a place where it makes it easy as possible. So, so on the bottom of the units, you'll see this remote control terminal. This one here, you would just remove this one screw, pull it off, pull the two leads up there and put the alligator clips on either the left side or the right side. So you would just pick a side and put it through there. Different manufacturers have different ways that you hook those external remotes up. Some of them are up inside of the unit, it clicks together, or you put it together many different ways. But if you are using an external remote, typically it's going to be this type of fashion. So before we move on to combustion air, any questions on remote controls? These units straight out of the box, if you don't have the remote control up to it, it's going to come set at 120 degrees. It'll work without the control up to it. They won't be able to turn the temperature up unless they have that controller hooked up to it. But it does not need the controller to actually run and operate. So any questions on the remote side or the electrical side? Alrighty, we will move on to combustion air. So with combustion air, so every appliance that's a gas burning appliance needs combustion air to operate. So in this, we'll kind of cover the combustion air, the proper venting, correct gas type, and what the flame should look like. So any flame with natural gas or propane should be a nice blue flame. If you're getting a yellow flame, you just don't have the right air to gas mixture that is there. So if you are pulling with tankless water heaters, you can pull combustion air from either inside the house or you can pull it from outside the house. Outside the house is always recommended because you're getting nice clean air from the outside of the house. Being able to pull in, the unit can breathe a little bit easier. It's going to work a little bit easier. If you're pulling from inside the house, there is different requirements. So if you're pulling combustion air from outside of the house, you need so if you are using, say, a louver, or you're using a combustion air run that's coming into there, for every 4,000 BTUs with outdoor air, you need 1 square inch on if you're using a big louver like this, or same thing with like if you have one of those big 8-inch pipes coming into that mechanical room, you need 1 square inch if you're pulling it from outside. Or 1 square inch per 4,000 BTUs of the unit that you're using. Excuse me. So if you're pulling it from inside air, you're going to need 1 square inch per 1,000 BTUs that you have there. So with these louvers, if you have a 10 by 20 and you're in the mechanical room and you're pulling combustion air from inside the house, you're going to need a 10 by 20 on the top, 10 by 20 on the bottom for that 199,000 BTU unit that's going to be in there. So these are all based off of the supplier combustion air in the National Fuel Gas Code. So it could differ between the municipalities, but typically with combustion air, they follow those codes. So I always ask guys, if you're gonna run 1 pipe out of the house for the exhaust, there should be, hopefully there's enough room to run 2 pipes. Combustion air with 2 pipes going out. But if you do have to pull it from inside, that's fine as well. Just make sure that you have that combustion air calculation correct for within that house. So areas where a direct vent or direct vent concentric is very highly recommended are salons, laundries, restaurants, places where hairspray, lint, grease, or there's just not enough combustion air within those spaces for that unit to run properly. Can't tell you how many times we've gone to places like restaurants or hair salons and things like that, and those fans have pulled in the hairspray and the lint and the grease and all that stuff and it's just gummed up that whole fan to where it can't even, it's spinning and it's going, but it's not pushing any air. So in those areas, it's very highly recommended to pull that combustion air from outside. So here's a couple of examples of bad combustion air. This first one, this unit here, is an older unit that requires that you run it in 3-inch PVC, and they bailed it down and went with 2-inch PVC. So this install would be great if that was 3-inch PVC, but it doesn't have enough combustion air coming in, so it's probably throwing a 90 code. This unit next to it, they blocked the air intake and the exhaust, so it kind of made a little bit of a bang inside of that unit and deformed that unit, which is never ever good. So make sure that you have it vented 100% correctly. So venting clearances. So within the National Fuel Gas Code, there are venting clearances to everything that's in there. So this is the actual table here. So here on the first one in A, this is clearance above grade, veranda, porch, deck, or balcony. When you're looking at these forms, make sure you're looking at the US and not the Canadian side. Always make sure you're looking at that US. So the clearance above grade, which is coming out of the house, here it's saying 12 inches above the grade, veranda, porch, deck, or balcony. They want you at least 12 inches up off the ground on that. Clearance to a window or a door that can be opened. So this is, so if you're running, say you were installing a power vent water heater that was only 40,000 BTUs, so inside of this over here, anything that is 50,000 BTUs or lower, you would only need to have a 9-inch clearance. But with tankless, you're going to be above 50,000 BTUs all the time, which is a 12-inch clearance. So for any window, door that can be opened, that is a 12-inch clearance. So clearance to a permanently closed window, so next to a window that's cannot be opened, there is no clearance, but there is a little asterisk here. So if you look down here at the bottom of this, that asterisk is saying that a clearance is in accordance, that we don't require a clearance, but local codes may be different. So if it doesn't specify here, you do have to go off the local code. So if your local code says you still have to be 12 inches away or whatever, you still have to apply by that. Typically, with a permanently closed window or something like that, it doesn't make a difference. They don't require that. But going through this, so unventilated soffit, we don't have a clearance. Clearance to the outside of a corner of a house, all these ones we do not have clearances to. So it would just go off of the local code, so which can leave that to, as I'm sure all of you know, some crazy interpretations. But one thing that I want to emphasize with everybody on this is, because I get a lot of calls on this, is this J. So J is clearance to a non-mechanical air supply inlet to a building or combustion air inlet to any other appliance. So we do a lot with new construction. So a lot of times the exhaust and the intake are coming out pretty close to where the furnace is. So this would fall within the intake and exhaust of being next to a furnace or a power vent water heater or whatever, you know, appliance is bringing its own combustion air into the house. So with that, our exhaust and our supply and our exhaust needs to be at least 12 inches away from our intake and their intake. So that is where that falls into. If you are installing in a retrofit application where they have a large combustion air that's coming into the house, that's when that falls into K. So got a lot of guys that, a lot of inspectors that have gone and looked at the K and said, look, you need to be 3 feet above or 10 feet to the side, when that's not the case when they're bringing their own combustion air into the house directly through the pipe system into the unit. So that's one thing I want to kind of clear up with everybody. They know that that right there is the two differences. J is if it's an appliance that's bringing combustion air through its own pipe into the house. K is if it's a great big louver that's bringing combustion air for multiple appliances inside the house. So one thing I get a lot of questions to is this L, which is clearance above paved sidewalk or paved driveway on public property. We do not have a clearance on that, but they interpreted that as property, not as private property, not public property. So they're saying like a sidewalk on the side of somebody's house. That is their own sidewalk, not a public area. So that's just a thing that the inspectors call all the time, which doesn't apply at all. So, so any questions so far? I know I've kind of covered a whole lot of stuff right there in that little sheet, but so basically, like with all of our units, if you're taking a combustion, taking 2 pipes out, your clearance from another appliance needs to only be 12 inches. So any questions on that?
So the intake and the exhaust coming off the tankless, if you're running it to exterior, just those two for the tankless need to be 12 inches apart, correct?
Yeah, so I'm going to cover that in the next slide. This one's talking about any other air inlets in the area.
Okay, so if it's a combustion air, like you said, like a big pipe coming in that's supplying more than one unit, it has to be 3 feet to this, or 3 feet above and 10 to the side. But if you're coming out next to something that has its own combustion air, you only need to be 12 inches.
Correct.
Okay, thank you.
So any other questions on that, on this part of it? Alrighty. So the actual vent of one of our units coming out, I mean, every manufacturer has a different way of what they say they need to have going out. So with our easy units, this is out of our easy book here. So if you're bringing 2 pipes out and you're on the same level coming out of the house, they want to make sure that that intake is 2 feet away from that exhaust. But if you're offsetting, whether you have one above or one below, it only is a 12-inch separation between those two. So if you're coming up and below, or you're coming out of the house and you're dropping your exhaust right next to the house and then taking your intake out another 12 inches and then dropping it, you have that 1 foot minimum. Most of the installs that we see, they're coming out right next to each other. The intake is dropping straight down, and then they're snorkeling the exhaust up 12 inches and 90 and out. So you have that 12-inch separation from the exhaust and the intake. So there's a bunch of different ways that you can do that. If you are coming in on that same plane at the same height, that exhaust and that intake needs to be at least 2 feet away. But if you are coming out at that same plane with the intake, you could actually cut a piece of 12-inch or a piece that's 12 inches long, and you could have it right next to one another like this, and then you have that piece of pipe coming down 12 inches. And once you have that 12-inch separation between those two, that's fine as well. So there's a bunch of different ways to do it. We went the rounds with the inspectors on this because they saw the 2 feet and then the 1 foot, and they said, well, if you have 2 feet up here, we require 2 feet everywhere, which is not the case. So every single one of these guys has been highly educated now on all of our venting clearances and everything here. So you should not have an issue with it, but we do have a bunch of different letters that we've sent out to a bunch of different municipalities out there to with our venting. So you should not have any issues on that side. But any questions on this? Because this sheet here is just specific to Noritz, which is pretty close to a lot of the different manufacturers that are out there too. But make sure that you're looking at the install manuals to make sure that all that is within their spec of their venting. So that's.
What about I've installed the vents that it blows straight out to the exhaust and then it draws the intake from behind. Are those acceptable?
Yes, so next slide is the like concentric venting, where you've got two pipes going into one picture. So this can either be installed horizontally or vertically, going out the roof or out the side. So this one, you're pulling combustion air right here next to the house, and it's exhausting straight out. So we always call these the bazookas because they look like bazookas going through the wall. So you can use those concentric terminations. You can use the flat wall terminations that the HVAC guys use for the furnaces. You can also use those types of concentric terminations with our units. But every manufacturer is different on what type of concentric terminations you can use. With ours, it is that bazooka one there, or those flat wall terminations that you can use going out there. Pretty much any concentric PVC termination is approved with our units. So just if you are coming off the top of our unit, so like our EZ and our NRCR units, it is 2-inch connections up there on top. So if for some reason you are upping it to 3-inch, you would just put a small piece of 2-inch pipe and then a 2 to 3 inch coupling or reducer. We ask that it is a belled reducer versus you putting a bushing into a coupling, just because that if you do it with that bushing in there, it could cause pooling of condensate in top of there. So we always ask that it is a bell reducer if you are going to be reducing it from 2 to 3. So here's a few pictures of some vent installs that are completely wrong. So this one over here on the left side, that's actually B-vent that they connected the top of this unit and then just kicked that 90 into a chimney. That is not an improved install. This one here in the middle, they actually have 3 racks or 3 units that are back to back on this little rack system that they built, and they hooked B-vent, or they hooked stainless steel, but then they hooked it into one big giant B-vent. As you can see, it's rusting out all over there from the condensation that's going through there, and they kept getting error codes and they didn't know why. We do have units that you can common vent together. In most of our units now, you can common vent together, but there are specific common venting guides that you need to follow to be able to common vent like 6 units together. So this one on the far side, so this is actually, we do make a unit that has a flexible polypropylene venting that's inside of this this is just a protective cover, but this they ran it out the side of the house and not up to the existing B-vent. So our flexible venting is not recommended to go horizontally. It goes vertically through the existing B-vent, not through the side of the house. Any questions on the venting and combustion?
So in most residential applications, the combustion and exhaust for a condensing unit is 2 inches or bigger. Is that correct?
Yeah, so all of the newer units that we have out on the market now, you can go 2-inch 65 feet or 3-inch 100 feet with those units. Either going to be 2-inch PVC or 3-inch PVC going out with those condensing units, yeah.
Awesome, thank you. So shorter than 65 is 2 feet, and then longer than that is 2 inches, and then longer is 3 inches.
Yes. So, okay. But with that, with every 90 that you add to that system, so you could be 65 feet with 2-inch, but that's just a straight length. You add a 90, you need to take 6 feet off of it. We actually have apps that you log into put your install in there. So if you're going 35 feet with 3 90s, it will tell you that yes, you can do that, and tell you what dip switches inside the unit to let the unit know what type of install it's in.
Okay, cool. Thank you.
Yep, no problem.
Hey, Gail?
Yeah.
Dude, what about venting underneath a deck?
So underneath a deck, which so in the National Fuel Gas Code, the clearance under a veranda, porch, deck, or balcony, there is no clearance there. So that would refer back to I've seen a ton of those installs where they've vented under decks, but it's all up to the inspector's interpretation of their local code of that happening. We don't require, we say we don't have a clearance on it, neither does the National Fuel Gas Code, but it is up to that local jurisdiction for that.
Okay, thanks.
Hey, Gail, one other question. Is there any circumstance where you can vent a non-condensing or a condensing tankless into a chimney?
We do, well, Centrotherm does make a chimney kit where you can put that, where you can either run 2 pipes into this chimney kit or a single pipe into the chimney kit. But they do make a kit where you can actually throw it down that chimney to vent those units up and out.
Okay, the picture you had, did it not have any venting?
Yes.
That one there,
Yeah,
it would send it into the chimney.
Yeah, that it just has that P-Vent 90 that they just put a hole in the brick and then just masked it off. And so it was just atmospherically venting into that chimney.
Okay,
With no liner or anything inside that chimney.
gotcha. What's the purpose for that? Not being able to do that.
Yeah, so inside of that chimney, like if you don't have that going up and out, because those units have those fans that are running and pushing,
Right.
if you don't have, if that chimney is not ventilating out properly and it starts causing back pressure in there and that fan can't exhaust, it's going to start pushing flue gases inside the house.
Gotcha.
So they want to have that chimney kit put in the chimney so it's venting correctly out of there. Because a lot of those chimneys have caps that aren't letting it vent correctly. They weren't built for that pressure of that fan pushing the flue gases up and out.
Gotcha, thank you.
So any other questions on that venting side? Alrighty, so then we will jump into the startup checklist. So once you've installed the unit, or even before you install the unit, make sure that the unit that you have is the right gas type. I was actually on a call for about 40 minutes yesterday with a customer that was having an issue with getting the unit to fire and keep firing. And I asked him the first time, is it a natural gas unit? And he said yes. And then we went through everything. And I'm like, are you sure it's a natural gas unit? And then he looked on the side and he said, no, they gave us a propane unit. So make sure that the gas type, number one, is correct for your install. 2, every manufacturer has different settings that you have to set within the unit to make sure that the unit is set for the install that you're in. So with our units, we have dip switches. So you would set a dip switch for the elevation and you would set a dip switch for your vent run. And if you're pulling combustion air from inside the house, you'd flip a dip switch. We have a really easy app that you can put that into and it tells you exactly what dip switches you need to press so you don't have to go through the manual. But if you don't have those dip switches set correctly, a lot of times it'll actually run for quite a while before it'll start throwing error codes, but it will start throwing error codes. So the dip switch settings need to be set correctly. Gas pressure, make sure you have enough gas and that the gas pressure is actually correct. So with our units, with natural gas, it's 3.5 inches water column to 10.5 inches water column is that working pressure, which you're going to find that everywhere here in Utah. With propane, it's going to be 8 inches to 14 inches water column. So if you are doing a propane install, it's always a good thing to check to see if that inches of water column is below 14. So I've seen a lot of propane districts where they're above 14, where they're 15 or 16 inches water column. If the gas pressure is too high, the unit's just not going to light, or it'll light and go right out. So if that gas pressure is too high, it just will not light. Same thing if it's too low, it'll light and then go straight out. So if you are working with tankless water heaters, the tools that you really want to have is a gas manometer and a Phillips head screwdriver. And those are pretty much the tools you need to have to work on a Noritz tankless water heater, because you can take apart everything inside that unit with a Phillips head screwdriver or your hands. Everything is either clips or Phillips head screws. It's pretty sweet. So verify that the dip switches are set correctly, the gas pressure is good, your combustion air is adequate, and that your water quality, you have something that's addressing that water quality issue. So once you first start up that unit, especially if you're doing a retrofit and they have galvanized lines, run the unit for a few minutes and then turn off the water and check that filter going into the unit, because if you were working on something where, or it's old copper lines too that might have a lot of scale in it, that with you working on it is knocking things off, just make sure that that aerator, or not the aerator, the incoming filter screen is just cleaned out before you leave. Or if that thing gets too gunked up, you're not going to get flow through the unit, it's not going to fire, and you're going to get a call back on that. So make sure that you test fire the unit at low flow demand and at high flow demand. So low flow is just turning on one single faucet, making sure everything's going. High flow demand is turning on 2 or 3 tubs and making sure everything is going. If you are installing more than one unit, we can multi-system control up to 24 units at the same time. But if you are using 2 units and you have like a quick connect cord going between the 2, you can verify, make sure you turn on enough water where it's actually going to kick on the second unit to make sure that both units are firing and they're staging between it. So if you are putting like 2 units together, it's a larger home. Those units are going to modulate which one's primary, which one's secondary. Every 8 hours of burn, it'll switch over which one's primary and which one's secondary, so you get a very even usage over the units over time, versus doing like 2 tanks in parallel where the first one does all the work and the second one just is kind of a storage tank. Those tankless units are going to switch off which one's primary and which one's secondary. And to do that, it's just a simple little cord that connects the 2 together if you're doing 2 units. If you're doing 3 units or more, then it is a system controller that you would put in there to control the whole system. So recirculation, I mean, we do have units that have recirculation pumps built into them. If you are adding recirc to a unit that does not have a recirc pump put into it, we actually make a little kit that has it's a Grundfos pump, but it connects into the unit. The unit controls the pump. It's pretty cool. But if you are adding an external pump to any tankless water heater that's out there on the market, first of all, make sure you're adding an expansion tank to the system if you are going to be adding recirc to it. And then that pump that you're choosing to put in there, just make sure that that pump is at least 2 gallons per minute or more. Even though that unit only has a ½ gallon per minute to fire, you want to have something that's large enough that if you've got 33 feet of head pressure going off there, that 2 gallons per minute might drop down to 0.4, 0.3 gallons per minute, and it won't fire that unit. So you want to have something that's 2 gallons per minute or more. That's kind of the rule of thumb to make sure that that unit's going to fire correctly. So if you are adding that recirc pump in there, just make sure that you have enough gallon per minute, that you add an expansion tank, and that you have it controlled either with a timer or an aquastat. So a lot of manufacturers, if you aren't controlling that recirc with a timer and aquastat, it will void the warranty on the units. With our unit, if you do not use if you use our pump, it's connected to the unit itself, and so the unit controls the pump, and so you do not have to add a aquastat or a timer, because that timer and the aquastat is actually built into the unit itself. So you are more than welcome to add recirc to any existing tankless that's out there, but just keep in mind too that when adding recirc to a tankless water heater, it could bring the warranty down on the unit. So like our easy units, it's a 25-year warranty, but if you add a recirc pump to that unit, it takes it down to a 15-year warranty. Where I know with, I believe it's Navien, they have a 15-year warranty. You add recirc to it, it takes it down to 7 or something like that. I can't remember exactly what it is, but I know with different manufacturers, they have different things with that recirc. When you add a recirc pump to it, it will change the recirc, or it'll change the warranty on the unit if you add an external recirc. But if you have like our recirc unit that is a 15-year warranty, it already has the recirc built into it, it still has a 15-year warranty. So any questions with adding recirculation to tankless water heaters? Alrighty. So maintenance with tankless water heaters. So we've talked about the flushing and things like that, but some things you'll want to check when you are flushing those units is make sure that the power supply that's coming in, make sure there's nothing that's arcing or anything like that, that the ground is connected. There's no loose communication wires. The water, check the water treatment that they have, or the water quality that's already there. One good thing to do too is you can actually look at the incoming and outgoing water temperature of the unit and see to make sure that it is actually delivering the temperature that it's supposed to do. Clean the inlet filter that goes into the unit. Every single one of these units, ours, everybody else's, has a inlet water filter going into it. So that's something you want to pull out, clean out, which is very easy. You can just take a little brush, clean it out, run it under water, it cleans it out. The gas supply, you always want to make sure that that supply pressure coming in is still good. You can also check the manifold pressures. There's a little port on the manifold to make sure that after it goes through the gas valve, that manifold pressure is good. Check the flame color, make sure the flame color looks good going through there. Combustion air coming in, always check the combustion air when you're maintaining these units, because I've seen so many different things, from wasp nests to bird's nests to kids shoving tennis balls in combustion air, like all sorts of different things. So when you are servicing it and you are flushing it out, make sure you check all of those different things that are there. So the remote controls, so these are just a bunch of different types that we have. So this would be like our residential, commercial, and some of our smaller units that are very, very small that do not have controllers that come with them. They have just these little readout things that are here. So every manufacturer has maintenance monitors that are built into their controllers. So with ours, you can press the unit, the arrows up and the up and down arrow key, and hold it, and then you'll hear a beep, and it'll flash 03. So once you get to 03, you can press the up and down arrows to get to different maintenance monitors. So if we're ever called with an issue, or our tech support's ever called with an issue, they always walk everybody through these certain maintenance monitors to make sure that everything in there is correct. So, so it'll always pop up and it'll start at 03, but you can turn on the unit. You can go to maintenance monitor 14. It's going to give you the total flow rate on the unit. So it's basically showing you how many gallons per minute is going through that unit. So if, like the other day, I had a guy that added a recirc pump to a tankless water heater. And he says, hey, this recirc pump is not working. The unit won't kick it on. Nothing's working. It's not heating the water. The burner won't turn on. So we had him go to maintenance monitor 14. He turned on the pump, and maintenance 14 just kept showing zeros. So the unit was not sensing flow through that pump. Turns out the pump that they bought was just a small little half-inch pump that could not pump water through the house, so it wasn't even pushing flow through the unit, so they had to upsize to a bigger pump on there. But those are things you can look at to see. So instead of having to tear things down, go through tech support or anything like that, you could go to maintenance monitor 14 to see what that flow rate is. So a lot of things that we get to is people say, hey, the unit's firing, but we're only getting lukewarm water. We're not getting hot water. So we'll go to maintenance monitor 31 and see what the outgoing water temperature is coming out of the unit. So if that water is leaving that unit at 120 degrees, but you're getting lukewarm water at a fixture, then it is something in the plumbing system after the tankless water heater. So a lot of times when you do a retrofit on an older home, if they have a bad cartridge in a shower, so they got a bad Mullen 1222 cartridge in that shower that's letting the cold bleed into the hot side, they'll only get lukewarm water at that shower or at that tub until you change that cartridge out. So with a tank, you have balanced pressure within the house. So if you got 60 PSI coming in, you're gonna have 60 PSI on the hot side, you're gonna have 60 PSI on the cold side. With tankless, we have a throttling valve that's leaving the unit and you'll lose pressure over the heat exchangers. So with our units, it might be 5 to 6 pounds. Some manufacturers, it could be, depending on the flow rate, it could be 15, 20, 25 pounds over that heat exchanger. But that small differential with ours, with that 5 pounds, is letting that, if you have a bad cartridge, it's gonna let that pressure push through and it's gonna let cold bleed into the hot side, so you're only gonna get lukewarm water. So that's one of the things that if you ever run into that, always check that maintenance monitor. It'll show you that 120 degrees is leaving that unit and that it is something actually inside the house that's causing that cross connection versus something wrong with the actual unit. So there's a ton of different maintenance monitors that are in there. So if it is flashing error codes, through 91 through 98, it's going to show you those 9 last error codes that it flashed. So you can see exactly what's going on with those units. So those error codes are very specific to different things inside of our units. So before we move to the error codes, does anybody have any questions on these maintenance monitors or on the things you need to check when maintaining the units? Alrighty. So these are the most common error codes that we see out in the field. So 11 is a ignition failure. So this could be a multitude of different things that an ignition failure is. So basically it's saying that it's trying to light and it cannot light. So first thing, always check, make sure that the unit is the correct gas type. With that ignition failure, make sure that your gas pressures are within parameters, because again, if it's over that pressure, so if you've got a natural gas unit and the maximum is 10.5 inches water column, and you've got 13, 14 inches water column, that unit will not light because the pressure is too high. So it could be wrong gas type, it could be the pressure's too high. It could be like the one that I went to about a year ago, was a 6-plex. And the guy called and said, hey, every single one of these units is throwing an 11 code. There's something wrong. We asked if, bled the gas lines. That's one thing too, is if those gas lines aren't bled and you've got a lot of air in the system, make sure you're bleeding those gas lines to get the air out of the system. So we went out to take a look at it just to see what was going on. And Questar hadn't set the meters yet. So there was no gas going into the 6-plex. So that's, so if you don't have gas, it's going to give you an 11 code too. So just make sure that you have gas, the air lines are bled, all of that for that 11 code. And that's typically what you're going to see on that 11 code. So 12 is a flame loss, which means it lit, the temperature sensor, or the flame sensor saw flame, but then the flame went out. So typically with a 12 error code, it is either one, it doesn't have enough combustion air or inadequate combustion air, or 2, the gas supply is too small. So they don't have enough gas coming into the unit, or the inches of water column got below the set point. So we've seen it where they've got 5 inches of water column coming in, they go to light the unit and the water column drops to 2 or 1 or 0, or it just drops. And there's just something wrong with either the meter or the main regulator coming into the house on that, but that is what a flame loss would be. So 14 and 16 kind of go hand in hand, because 14 is from some of the older technology units where we actually had an overheat cutoff fuse that was wrapped around the heat exchanger, where if that heat exchanger got too hot, it would actually burn that fuse and separate it, and you'd get a 14 code. With the newer units, it is a resettable thermal switch on the actual top of the unit. So if that heat exchanger gets too hot, it will flash a 16 code, or in the older units would flash a 14 code. Biggest contributor to this is scale buildup inside of that unit. So if they haven't flushed the unit or taken care of the unit, that scale will let the unit get too hot and get that heat exchanger too hot to where it will overheat and throw those error codes. So if you ever had an older unit that's getting a abnormal high outlet temperature or an overheating cutoff fuse, that would be the reasons for that. Also with that 16, if it's a water temperature outlet, then that would mean that mixing valve that is supposed to be there to temper that water has gone bad. So you would just need to replace that. So 29 is going to be your condensate or your condensate collector water abnormality, which just means there's a little sensor in there that if the water level gets too high inside of that trap, that it will set that 29 code off and shut down the unit so it doesn't back condensate up inside of that unit. So that just means that there's a block inside of that condensate system somewhere from the trap internally down to the drain. A lot of times it could just be a whole bunch of buildup that's gotten blocked off in there. Best way to fix that is that condensate collector. You can just dump water down the exhaust and it'll actually flush out the condensate line. So 51 is failure of a gas solenoid, which just means the gas solenoid failed in the unit. So there's a ton more error codes that are in there that are very specific to different things. These are just the top ones that we see. 65 is that main water control valve coming into the unit has gone bad. 66 is the bypass water control gone bad. So one unit or one error code that's not on here that we see a ton of is 73. So a 73 is a circuit board abnormality. So, but the 73 code is, what that means is you had the unit plugged into the wall and you flip dip switches. So just like a computer, if you add a program or change anything to your computer, you have to restart it. Same thing with a tankless water heater. If you're flipping dip switches, it's reprogramming that board. So you want to make sure that you have that unit unplugged before you start flipping those dip switches. So unplug it, flip your dip switches, plug it back in. If you do get a 73 code, just means that you flip dip switches with the unit plugged in. All you have to do to reset that is unplug the unit and plug the unit back in. So same thing with any error code that is on one of our units. If you get an error code, you can fix the error code or clear the error code by unplugging the unit, waiting 15 to 20 seconds, and then plugging that unit back in. So F76 is a quick connect transmission problem, which just means you have two units, the cables connected, but for some reason they can't talk to one another. A lot of times with that is it's usually something's wrong with the cable or it wasn't connected properly. So with those quick connect cables, it connects to the unit, but then there's also a ground wire that grounds to the ground board. If you don't put those grounds on there, you'll get that 76 code. And then the most common error code that we see all the time is 90 for bad combustion. So 90 just means that your combustion air coming in is not sufficient, or it's not getting enough combustion air. So that's when you would want to check that combustion air. If you have enough combustion air, if there's something blocking that combustion air. I had one about a year and a half ago where they kept getting 90 codes, and the contractor couldn't figure it out. So I went out to the house, and they they painted the house about a week before, and they masked off the combustion air going into the house. So it worked fine when it was at a low BTU because it could pull enough combustion air from inside the house around the door, but then when it got to that high fire, it couldn't pull any combustion air, and so it would shut down. So those are the most common codes that we see out there. Any questions on those error codes before we move forward? All right. So checking that inlet water filter, it just screws straight out of there. In the end of there, it's like a flathead screwdriver. So if you have a large flathead screwdriver, if you can't get it out with your hands, you can stick that in there, or you can stick a quarter in there too. You can slide a quarter in there, it'll pop that open. Just unscrew this back out. This little screen right here, there's an O-ring right here. It just pops out of there. You can see this one has a whole bunch of debris and stuff in there. You can just use a brush, run it underwater. It'll clean it up. And you can just put it back in. You don't need to replace it. If it gets so bad that you can replace it, they're only like 25 cents. They're really cheap to be able to replace those. So when you are descaling that unit, the things that you would need to descale that unit are just washing machine hoses, a 5-gallon bucket, a submersible pump. I've seen guys use transfer pumps too in that. And then, so if you're using like a CLR, the calcium lime rust stain remover, and then dilute that with either a gallon of water, so a gallon, 50-50 mix of that, or food grade vinegar works great. If you have a unit that is regularly being flushed, food grade vinegar will work just fine. If you've got a unit that's an older unit or that hasn't been flushed in 3, 4, 5, 6 years, using a calcium lime rust remover or something like that that's more aggressive will work better on those units that haven't been flushed in a long time. But typically, if you're doing the maintenance on a tankless water heater, you're flushing it every year, that food grade vinegar should work just fine on those. So additional maintenance while you're there, you can clean out the burner chamber, clean the igniter. If you are going to clean the igniter that is on a tankless water heater, on here it says a Scotch-Brite sponge, but don't use sandpaper, emery cloth, or something that aggressive on that flame rod. I've always used a dollar bill to clean those flame rods. A dollar bill is just enough to clean it but not damage it. But inspect water lines for leaks, inspect the venting for any damage, inspect that gas line, make sure that there's no leaks in that. And then always check that pressure relief valve to make sure that it's working properly. It works just like a TMP. You just pull it up, it'll shoot water out of it, you let it go, it'll shut off. So any other questions on anything that we've covered so far? All righty. So, as I said before, we do have an app called the ProCard app. With that, it does have gas pipe sizing. It does have this little circuit dip switch settings here. So if you are installing one of our units, you can just put in there the install of what you're doing, and then it'll bring up which dip switches you need to press. On that app too, it'll give you, if you're working on older units, it'll give you the owner's guide, parts list, tech data sheets, the service manual, how to replace a heat exchanger, how to descale that unit. It works with all the new units too, but it will give you literature on any one of our units all the way back to 2000. There's also an interactive troubleshooter, so if you do get an error code, you can actually put that error code that you have into the interactive troubleshooter, and then it'll give you step-by-step instructions on how to fix that error code. So like this one's a 90 code, which is a combustion abnormality. It's going to walk you through step by step. So like this one's going to say, is this installed above 2,000 feet? You hit yes, you hit next. It'll walk you through how to make sure that it's set for high elevation. So it's a pretty cool app. We have a ton of installers that use it every single day. It saves people bacon quite a bit. So, but that is everything that I have for you guys today. Does anybody have any more questions or anything?
So in Utah, since we have obviously such hard water, you'd say at a minimum, without a softener, they need to flush it minimum once a year.
Yes. Yep. And depending, like I live in Harriman, my water's 40 grains hardness out
Holy
here.
crap!
Yeah,
Wow.
It's bad. I mean,
It's like a mud puddle.
Yeah, I mean, I've got a softener and some carbon filters and stuff on my house, but we have a ton of, like, Edge Homes does a ton of work out here with us, and you know, to maintain that warranty, those homeowners need to flush that tankless every single year, which they're doing, and it's been working great. They've been installing out here since 2017, and these units have been working awesome. So if they're flushing it once a year, you know, when you get really aggressive, I mean, we would love to see them put more than just flushing it once a year, you know, doing something you can water, because not only is it going to hurt, it's not really hurt the tankless water heater, but I mean, like my neighbors across the street had to replace their faucets for the first 3 years every single year.
Right. Yeah.
So if it's doing that to the faucets, like what is it doing to those what is it doing to those valves in the wall too?
Right.
So, but yeah, I mean, water treatment, even with tank water heaters, even though they recommend them when it's very high. So, but at least have it flushed once a year.
Right. Right.
So, any other questions, guys?
Well, Gail, thank you very much. I appreciate the training. It was very informative and well presented. I just ask everybody who is online to send me an email, because many of you were registered by others and I don't have your contact information and your license numbers. So send me an email. I've given you that email on the chat feature online on the GoToMeeting. So with that being said, this will be, I will upload your credits to Doppel Monday or Tuesday. You'll get 2 hours of core credit on this. It was, and we look forward to doing other training. We have other webinars that have been recorded prior to this that you can go on and get your hours that you need as well. So thank you very much, everyone, and we'll see you another time. Thanks, Gail.
All right, thank you. Thanks for having me. I appreciate it.
Thanks, Gal. We'll see you.
All right, thanks, Vic.
Thanks. Appreciate it.